Hi Math 137 friends, welcome to 9.2 Multiplying and Dividing Rational Expressions. Our last section was simplifying rational expressions. Today we're going to multiply and divide. It's always going to be assumed that we will simplify, so you are always expected to simplify. So if you are asked to multiply, assume that you have to simplify the result. If you're asked to divide, assume that you also have to simplify the result. All right, so let's start with two very simple rational expressions, just fractions. If you were asked to multiply 7/3 by 12/35, don't overthink this. Remember, multiplying fractions is the easiest algebraic operation to do. When we multiply fractions, we just simply multiply across. We multiply numerators and we multiply denominators. All right, now before we actually do the multiplication, we can cross off, we can identify common factors in the numerator and denominator and cross them off. So notice 12 shares a common factor with 3, which is 3, and 7 and 35 have a common factor. So we can mentally break this down, or I'll write it out for demonstration purposes. And then I'm going to write 35 as 7 times 5. So and then I can in turn cross off the common factors and get a final result of 4/5. Now we could have, and 4 and 5 don't share any common factors, so we know that that's our final answer. Now we actually could have done the multiplication. We could have gone from here and done 7 times 12 and gotten 84. And we could have done 3 times 35 and gotten 105, but 184 over 105 is not simplified. They share a common factor of 21, which is not as obvious as seeing that 12 and 35 and 12 and 3 share a common factor. So my suggestion is to factor and simplify before you multiply, regardless of what the rational expressions look like. So again, this is just 4 times 21 over 5 times 21, which is not obvious. Would cross off the common factor of 21, and in the end, we would still get 4/5. So this was the easier route. So you want to factor, then simplify, and then if there's anything left, multiply. Here, when we eliminated the common factors of 7 and 3, all that was left was 4 and 5, so we didn't have to do any further multiplication. But you will see that we will get to that. All right, let's take a look at 3x squared over 10 times 40 over x to the 4th. So my suggestion to you is to just multiply across, but don't actually do the multiplication. Just think that this is just 3 times x squared times 40 all over 10x to the 4th. And we're eventually just going to eliminate this step right here because it's just a little bit of extra work. And now we're going to look at to see what factors the numerator and the denominator share. Well, 3 doesn't seem to share anything with the denominator, but 40 and 10 share a common factor of 10. Also, x squared and x to the 4th have a common factor. So I'm going to rewrite this as 3x squared, and I'm going to write this as 10 times 4 all over 10, and I'm going to rewrite x to the 4th as x squared times x squared. I'm going to break it down into x squared times x squared, so then I can cross off the common factor of x squared, cross off the common factor of 10. Now 3 doesn't have any common factors with x squared. 4 doesn't have any common factors with x squared. So now we have 3 times 4 on top and x squared on the bottom. So first thing we did was factored. Then we simplified. So here is, I just put this all into one fraction, and then we factored. Then we simplified by crossing off common factors, and now let's finish this off by multiplying. 3 times 4 is 12 all over x squared. And that would be my final answer. Factor, simplify, multiply. Okay, we could have factored right here in this step and crossed up the common factors without actually combining it into one fraction, which is something we typically do in practice. So let's take a look. Let's suppose I said, let's multiply the rational expression x squared minus 8x all over 4x times 12x squared over x squared minus 64. So you can see that these are already getting considerably more complicated looking. But if you're good and comfortable with your factoring skills, x squared minus 64. Now I'm just going to factor right here, x squared minus 8x. The only thing that we have in common here is this isn't a trinomial, it's not the difference of squares, but I can pull out the factor of x. So I'm going to change x squared minus 8x to x minus 8. 4x is about as small as it can be. Now remember, our goal is to look for factors, common factors in both the numerator and the denominator. So 12x squared, well, we can pull out a factor of 4x and rewrite this as 4x times 3x. So 12x squared is 4x times 3x. It's also 6x times 2x, but that's not going to help me to cross off the common factor of 4x in the denominator. So thinking ahead, I knew that I could pull out a factor of 4x and those will eventually cancel. And then x squared minus 64. Well, that's the difference of squares, and that factors nicely. It's x minus 8, x plus 8. Ooh, I ran out of room almost right there. All right. So now we could rewrite this and multiply it all together, but I'm just going to extend this and just do that. Save ourselves some time in writing. So we factored. Right now we're going to simplify. We're going to cross off common factors, keeping in mind from our last section that factors themselves can contain addition and subtraction as long as it's contained within the parentheses. So notice this entire x minus 8 crosses off with this entire x minus 8, including the parentheses. I'm going to cross this 4x out with this 4x. And then I have x and 3x on top and just x plus 8 on the bottom. So it looks like I've done all the simplifying I can. Now I'm going to multiply. X times 3x is 3x squared all over. All that's left is x plus 8. And that is my final answer. All right, so not too terrible, right? The better you are at factoring, the easier this section is going to be. Factor, simplify, then multiply it all together. All right, so that wasn't too bad. We're going to take this up a notch, though. Multiply 4x squared minus 1 all over 2x squared minus 9x minus 5 times 3x squared minus 13x minus 10 times 9x squared minus 4. All right, this may look really horrible. So my suggestion is when you're in this situation, we want to factor. We have 4 different polynomials we can factor here. We have the left numerator, the left denominator, right numerator, right denominator. We want to factor all of these guys. Now, for the sake of this class, often nice things happen. Not always in practice, but because we're new at this, it's very likely that these things are going to factor nicely. I might need a little more room than that. They're going to factor nicely, and we're going to see common factors in the numerator and the denominator that we can cancel out. So what I look for is look for the easiest ones to factor. You can use the AC method for these guys. You can guess and check. I'm not sure if you noticed, but these are both binomial expressions and their difference of squares. So this is just 2x squared. So this is really just 2x squared minus 1 squared. So we know that that factors nicely. 2x minus 1 and 2x plus 1. And I told you at the start of the semester, the better factor you are, the easier the later sections will be, and this is definitely holds true here. Now notice 9x squared minus 4 is also the difference of squares. 9x squared can be written as 3x in parentheses squared, and 4 is just 2 squared. So I pretty easily factored the left numerator and the right denominator. All right, so now we want to factor the left denominator and the right numerator. Now, you can use the AC method, but I'm going to suggest we do some guessing and checking here. So in order to factor this guy, remember the product of the first terms has to equal 2x squared. So the only thing, if this factors nicely, It would have to be 2x and x. That's the only two numbers that we can, 2 and 1 are the only numbers we can multiply nicely to get 2x squared. So, and then I look up and I'm like, we have a factor of 2x minus 1 and 2x plus 1. So thinking ahead, I'm going to assume, this is a guess, but it's a very educated guess, I'm going to assume that the constant in the parentheses with 2x is going to be 1. We're not sure if it's plus or minus yet, but that would be really nice if it was either 1 because then it would cancel out with that factor in the numerator. So now remember, I'm factoring the left denominator here. So 2x and x gives me 2x squared. Now the product of the lasts has to be negative 5. So if I'm going to assume this is 1, again, a good educated guess, we have to make sure we check this is going to have to be 5. So let's check. Product of the first, 2x squared. Product of the last is 5. We just have to decide which one is negative and which one is positive. Well, I need negative 9x's. So in order to get negative 9x's, the 2x and the 5 will give me negative 10x's. So that's what it's going to be. It's going to be plus 1 and minus 5. Now, if you chose the signs incorrectly and you put the minus here and the plus here, you would get the correct number 9 in the middle. It would just be positive instead. So let's just double check. Product of the first, 2x squared. Product of the last, negative 5, which we need. We have 1x in the middle and negative 10x's on the outers, which is my negative 9x. Woohoo, we did it. So notice these are going to cancel. We'll get to that though. All right, now we're going to do the same thing over here. This could be a tricky problem if you use the AC method or you keep guessing, but let's use educated guesses. I know that this has to be 3x and x in order to get 3x squared. So we started out, fortunately, with our leading coefficients in both these trinomials were prime. This had to be 2x and x. That had to be 3x and x. So now we have to decide what's going to go here. But my eyes look down and I say, ooh, look, we have 3 x's with 2's. So it would make sense that this is a 2. It doesn't always work, but it's a good guess, and then we can check. So if this is 2, in order for the product of the last to give me 10, this has to be 5. Woohoo! So we got through the 3x, and the 2 is going to cancel with one of these. Oh, I see x minus 5 over here, so I'm going to make a good guess of x minus 5 over here. Well, if that's minus 5, this is negative 10. That's going to have to be plus 2. So let's check. Product of the first. So this was a guess. A good educated looking ahead guess, 3x squared. Product of the last is negative 10. The inners give me 2x's. The outers give me negative 15x's, which is negative 13x's. So there we go. We just factored 4 trinomials, and it didn't take us all that much time. We just used what we knew about factoring and looking ahead based on the type of problem this is. So we're multiplying. We change 4x squared minus 1 over 2x squared minus 9x minus 5. To this. And we changed, I'm not going to say the whole thing, but we changed this to this. So we factored. Now we can cross off. Now remember, when we multiply these two together, they're just going to become one fraction with the left numerator times the right numerator and the left denominator times the right denominator. So now I'm going to cross off my common factors. The 2x plus 1's cancel. The 3x plus 2 cancel. And check this out. The x minus 5's also cancel. So look what's left. 2x minus 1 over 3x minus 2. Factor. Simplify. Multiply. Factor, simplify, multiply. Now, do not make the mistake of crossing these x's off. I mentioned this in the last section. You can only cross off common factors. This x is part of this term. You may not cross these off and get 2 minus 1, which is 1, over 3 minus 2, which is 1. It would be 1 over 1, and this is definitely not 1 because those are not the same. So this is the end. You may not cross those x's off. Do not do that. It is not correct. Factor, simplify, multiply. So that is multiplying rational expression, sorry. All right, let's continue. Let's divide rational expressions. If you can multiply rational expressions, you can certainly divide rational expressions. You just have to remember a key trick from like your elementary school days, dividing fractions. We have a trick. Does anyone remember the trick when you're dividing fractions? Well, we don't divide fractions. We keep the first fraction, change the operation to multiplication, and we flip the second fraction. Keep, multiply, flip. So dividing by a fraction is the same as multiplying by its reciprocal. So the only extra step here when we divide, we change a division problem into a multiplication problem, and then do what we just did in the last two problems. Or three problems, whatever we did. Anywho, this is going to be, well, I'm going to look for common factors. 2. 15 and 45 have a common factor of 15. So I'm going to leave that 15 alone and change 45 to 15 times 3. And 8 and 2 have a common factor of 2. I'll change that to 2 and 4. And then I'm going to cross off that. Oh no, that's left is 3/4. Right? So the key here is to change your division to multiplication. I'm sorry, yep, to change your division to multiplication. So if you're dividing a fraction, we leave the first fraction, change the operation to division, and we multiply by the reciprocal. All right, corny cloud with stars. Haven't seen one of these in a while. But that is the key to dividing any rational expressions. All right, a couple more problems for practice. All right, x minus 4 over x squared minus 2x minus 8 all over 3 divided by x plus 2. We're doing division here. So instead of rewriting the whole problem, I'm just going to keep the first fraction as is. I'm going to change division to multiplication. X plus 2 all over 3. All right. Now this one's kind of nice, easy, because this is totally, we can't do anything with x minus 4, x plus 2. The 3 is just 3, but we can factor that guy. So we're going to take the next step and we're going to factor the left denominator, the only thing that has the possibility of factoring. Again, you want to be a good factorer. Nice things happen when you're a good factorer. X plus 2 over 3. And this will be x and x. Looking for two numbers whose product is -8, but whose sum is -2. So it looks like it's going to be 4 and 2. And I need -2 x's, so the larger number is going to dominate. Right. Now we can rewrite this all together in one fraction, or I kind of cheat and I just do this to save us the hassle of writing it all over again. And now we cross off, so we factored, simplified, and then we're left with, all right, oh, well, what happens here? Okay, we can never leave a numerator or a denominator empty. If there's a 1 in the denominator, we can write it without that particular value in the denominator. But the problem is here, be careful, this isn't 0. Always there's the unseen factor of 1 floating anywhere in that numerator. So if you cancel out all the factors, there's always the remaining factor of 1. So you don't change it to 0, because 0 is not a factor of the numerator, but 1 is. And do not leave numerators empty. And that's it. All right, so let's do one more tricky one like we did last time, where it looks really difficult, but it's not all that horrible if we think ahead. So again, I'm not going to rewrite the whole division problem, but I will write it as a product. So I'm going to write 3x squared minus 25x minus 18, which looks terrible to factor. 27x plus 18, well, that's a little binomial, and that's really super easy. Excuse me, we just pull out the greatest common factor. And then we have 5x squared minus 3x minus 2 over 5x squared minus 43x minus 18. All right, and I'm going to start with the easiest to factor. 27x plus 18. Well, all we can pull out is a greatest common factor, and we get 3x plus 2. So now I'm going to look up here at this guy. So my good educated guess is that we don't have a choice of 3x plus 2 or 3x minus 2 like we did in the last problem, but this has to be, if this factors, we have to have 3x here and x here. So my educated guess is, well, let me see. I'm actually going to write these guys over here too, so you can see what my thought is. This has to be 5x and x. This has to be 5x and x in order to get 5x squared. So we're very happy when the leading coefficient is prime because those are our only options. Now 3x plus 2, well, this could be 3x plus 2 here. This one won't be, and neither will these. So it would be really nice, thinking ahead, if that's 3x plus 2. Now remember, this isn't a guarantee, but think ahead, and let's see if it works. Well, if this factor is 3x plus 2, in order to get the minus 18 on the end, what number do I have to put here? Well, 2 times negative 9 is 18. So this would be super convenient if this factor was 3x plus 2. If this factor is 3x plus 2, this one has to be x minus 9 to get the negative 18. But we have to check. The inners give me positive 2x's. The outers give me negative 27x's. Well, positive 2x minus 27x give me the minus 25x. Not always, but often, more often than not, in this section, you will be able to logically come to the conclusion what these factors are. So 3x plus 2 and x minus 9 is that one. So that wasn't all that horrible. We're going to guess, but we're going to think ahead and do good educated guesses. All right, so now you might be like, whoa, we are super stuck over here. But I know that these guys are going to cancel. So keeping in mind that I have a factor of x minus 9 in my left numerator, it would be super awesome if I had a factor of x minus 9 in my right denominator. Well, this can't be x minus 9, so maybe that could be. So now again, we're just thinking ahead. It's no guarantee, but it's a good place to start. And that looks kind of nice because that's negative 18. If this is negative 9, then we know we have to have a factor of 5x plus 2 here. So that's just a guess. Looking ahead, it would be really nice if we had the factor of x minus 9 here because of that one. So let's check. 5x squared, product of the last, negative 18. We have 2x's minus 45x's. Look at that. Again, it often works nice. Not always, but you can try this to think ahead. If you don't like what I'm doing, you're more than welcome to go use the AC method or however you want to factor. But again, if you can use some logic here and some problem solving skills, you can do these problems a lot quicker. All right, so now all that we have left is 5x squared minus 3x minus 2. Well, this is a 2, so that has to be 2 and 1 or 1 and 2. Well, again, wouldn't it be really nice if this was plus 2? Not a guarantee, but if it was plus 2, then those will cancel out. Well, if that's plus 2 to get a last term of negative 2, that would have to be negative 1. Let's see if it works. Product of the first, 5x squared. Product of the last, negative 2. Inners, positive 2x. Outers, negative 5x. Look at that, negative 3x. 2x's minus 5x is negative 3x. Woohoo! There we go. Factoring. We just factored 3 very difficult polynomials that in previous sections we would have had taken considerable amount of time either guessing or checking or using the AC method. But here we started with the easiest one, pulled out the greatest common factor, and then used this one factor to make this little trail of all the other factors. So we factored. Again, you can think of this now as one fraction with everything in the left numerator times the right numerator, left denominator times the right denominator, and we are now going to do the exciting task of crossing off all the common factors. 3x plus 2 crosses off, x minus 9, 5x plus 2. So this horrible problem, what looked like a horrible problem, worked out to be super nice. All that's left in the numerator is x minus 1. All that's left in the denominator is 9. The end. Let's see. To do. So I know you just had a test, but keep going, you guys. We are so close to the end. I can see it. Just several sections in 9-2, just a couple sections in chapter 10. Or I'm sorry, several sections in chapter 9, including 9-2. Read 9-2. Exercises. We are going to do 1 to 21 odd. The more you do, the better you're going to be at these, guys. 31 odd, 37, 39, and 43. Alex, you can now do 9.1 and 9.2 topics. And 4, 22. You're going to be at 33% more, or 5+ hours. All right, you have another test 3 weeks from this Thursday. So your next test is on May 5th. So this coming week, or next week's goal is 33%. The week after will be 66%, and then the week after will be 100% for your last chapter test. And then you'll be preparing for your final exam. All right, everybody, have a good one. Talk to you later.